Thank you so much. So today's webcast is about the SQL support that we have on Apache Apex. I am Chinmay. I'm a committer at Apache Apex, and with me I have Vikram, who will be the administrator for today's session. And just some quick logistics. If you have any questions to be asked, you can type in the question window there, and we'll make sure that they are answered immediately and promptly. But if you want to ask your questions yourself, I'll be taking a logical break at every other step, and you can raise your hand, and that is when you can ask your question there. We'll unmute you at that point of time. Okay. So let's go ahead and start the session. So at the beginning, we'll cover a little bit about Apex and what Apex stands for. So Apache Apex is basically a streaming engine, which uses one of the popular framework provided by Hadoop, that is Yarn, and it is used to process the data at real time rate. There are some key aspects where Apache Apex stands out is easy operability, and we should stress a lot on this point that Hadoop being a very complex infrastructure, we don't want users of Apex to spend too much time on logistics and other related aspects. So one of the goal of this community is to make the life of user of Apex as easy as possible, and that's where we have provided very easily accessible APIs for developing operators and applications as well. And as we get newer feedback, we are trying to make the improvements even further. The second important aspect is very highly scalable platform. So what that means is when you develop a pipeline, or when you develop what we call as DAG in Apex, sometimes a part of the pipeline might be very resource intensive, something like, let's say, string parsers and some deduplication of operation and so on. we allow that particular piece of pipeline to be scalable, and we call it as partitioning. And the scaling up of those operators can become dynamically as well as statically. So by statically, it means that right at the beginning of the application, we have a static partitioning of that particular operator, and dynamically it means that there are some conditions like a certain number of throughput or certain latency. If it reaches that particular point, it scales up, or if it goes below certain numbers, then it just scales down to save the resources and so on. So that dynamic partitioning happens in Apex. Thirdly, it's very high performant, and we have seen the results in production where we get the results of as less as 2 milliseconds for an end-to-end latency. And by end-to-end, I mean that a tuple has reached Apex platform, and when it finishes the processing, the latency is in few milliseconds. Fault tolerant. Now this is another very important aspects of any streaming platform, that when you are processing the data at the rate of millions and billions of events per second at such a less latency, there are chances of failures. There are chances of manual errors, or even data might be corrupt somewhere, and because of which the operators might fail at certain point of time. Other failures might also happen because of loss of node in the cluster and bunch of other things. So at that point of time, Apex takes the responsibility that we restore back the application from point where it is safely to be recovered from. Okay? And that is fault tolerance we provide. So this also provides another important aspect, that is guarantees. So we provide a couple of guarantees, like end-to-end exactly once. So that means the exactly once processing is happening over Apache Apex pipeline. The second is at least once and at most once are also provided. And one of the key reasons why we could do that is fault tolerant. Statefulness. This is also another thing which guarantees how the fault tolerance and the processing guarantees can be provided. What that means is operator logic can have states, and those get saved automatically by Apex platform, and user need not worry about that aspect. Now another very important addition to Apache Apex engine is Apex Malhar library. Okay, so this is a huge set of libraries where the operators are ready to be used in production environments. They are being tested in production environments, so that one need not worry about the development of operators. They can just focus on their business logic. So this is a great addition to the Apex platform. And lastly, as I said before, it is a Yarn native application. That means it purely uses Hadoop Yarn infrastructure for resource negotiation. Now, just to give a quick overview on how the platform looks like. So right at the bottom layer, we have physical, virtual, or cloud systems which are there, and we support all of them. The testing has been done on all of them. Built on top of that, one can deploy a Hadoop cluster. And Apex is certified with Cloudera, Hortonworks, Pivotal, Mapr, and even the vanilla flavor of Hadoop as well. It runs perfectly fine. Built on top of Hadoop and HDFS and Yarn is a streaming engine. That is what we call it as Apex engine. And this engine is a highly performant, fault-tolerant, and in-memory processing of data in motion. So all the features that we saw in the previous slide, all those are applicable at this layer. Now, using this Apex engine, as I said before, we have come up with an open source library called as Malhar. It has a bunch of operators which contains the business logics that people can directly use out of the box. And at the same layer, we can say that there are streaming applications where applications are built using these Malhar operators or any custom operators if you want to use, and application can be developed and launched. At the right hand side, you would see that there's another box called as REST API. Now this box is another critical box which makes sure that the correlation or the communication between these different layers happens very seamlessly. So these are the REST APIs which are again part of open source platform, are provided along with Apex engine. Now till this point we had the open source layer, and just as an information, I would like to tell you that there's another layer which is built on top of that DataTorrent has developed. So DataTorrent has a platform called as DTRTS, which basically contains a management console where you can manage various different streaming applications, Apex streaming applications, using that management console. It also has a graphical application design utility, which allows you to just use the operators which are present in your Malhar library or in your streaming application to just drag and drop and connect them on the fly and launch the application. So, and that also covers the configuration of the application. So that's also another value addition over Apex that DataTorrent has provided. And lastly, but not the least, this is something which CXO kind of guys or even the administrators would really like to look at, is data visualization dashboard. So any application that is running when the data is being run at millions of events per second, you would like to see what is really happening with the data, how it is processing it, and so on. And the numbers definitely does convey the information, but with such a large amount of information, it makes sense to have a graphical or visualization based dashboard to provide that information. So the data visualization dashboard feature of RTS platform allows you to quickly come up with the metrics emitted by the operators. They can be consumed, and very meaningful graphs can be developed out of it. So this is a layer which is these three components are built as a part of RTS platform of DataTorrent, built over Apex engine. Now, going ahead with a little bit of how application works in Apex. So Apex has a couple of different concepts. So the first concept that comes is an operator. So operator is any piece of code which contains a business logic. So this operator is going to take the data from its, we call it as input port, and it processes that data from the input port and emits at the output port. What connects between the two operators, or what communicates the data from output port of an operator to the input port of the next operator, is we call it as a stream. A stream is basically nothing but a network abstraction, and it basically works over a SSL or a TCP type of communication, where the data is flowing from one operator to the next operator. And what flows within a set of within a stream is what we call it as tuple. A tuple is nothing but a smallest unit of data that an operator can process. So if we take an example of, let's say, a parser, So a string at the input can become a tuple, and at the output end it might emit an object which is a parsed information about that string, and that we can call it as tuple. So definition of the tuple changes for every stream because it depends on how the operator is processing it. So this is how the typical example application can look like. So you can see that from the input source, the data can be picked up from message buses like Kafka, Solace, Bloom, or even file systems, databases, and some HTTP, FTP, Twitter type protocols as well. So we have all the operators, all the input adapters, as I can say, which communicates to the external sources and fetches the data at a real-time rate. The input operator then can send the data to what we call it as generic operators. Generic operators can process the data and eventually provide the output to some output adapter, which again talks to a destination place like message bus, file systems, databases, and some protocols. So you can see that there's a little bit of difference between the two types of operators here. So the blue ones are called as input ports, and the green ones can be called as the output ports. So you can see that the input adapter has no input port. So that is why the APIs of input adapter are a little different as compared to the APIs of generic operators and output adapters. So that is how the typical example can look like. Now, before we move ahead to the real SQL part, I just want to have a quick check that is anybody having any questions? You can raise the hand, or you can even type the questions in the box. So we're gonna miss anybody has raised the hands. No, all right, fine. If there are any questions in the chat window, you can just reply to them. Thanks. All right, let's jump on to the main topic of session today. So this is a history of SQL that I picked up from one of the presentation at Strata, New York, from 2014, which was presented by Julian Hyde. So he has given so by the way, Julian Hyde is a Apache PMC chair of Apache Calcite project. So he has given a little bit of history about SQL, and since 1996 till now, you can see that SQL has been very popularly used, and that is not just in a transactional sense, but later on after 2000, you can see that even Hadoop has the variants of it, like NoSQL. For examples of NoSQL are like HBase, Cassandra, and so on. Then the concept of SQL on Hadoop came up, where Hive and Impala and such projects of Apache came into existence. And finally, now it is at a stage where the analytics are also being done using a SQL language. So the question clearly comes up is why SQL is remaining popular. Now, the explanation for this is, first of all, it is coming from a long time, and it is a legacy language. People still do have expertise on this, and moreover, the systems are still in place. Even though systems are getting the older systems like RDBMS systems are getting replaced with NoSQL, people still have an expertise of SQL, and it is harder to find. It's harder to hire any people with a certain expertise instead of teaching them something new. So you just go ahead and keep the SQL alive. So that is the reason why SQL is still more popular, and we just took that opportunity to where we can say that SQL on Hadoop is provided in 2011. Similarly, we want to provide a SQL on a streaming application as well, and that is where we integrated with a platform called as Calcite. So Apache Calcite is another project in Apache projects which helps you use the SQL in your business logic. So let's quickly see how Apache Calcite works. Now this diagram is a traditional architecture of any database engine. Now right at the top of the layer we have JDBC clients, which communicates with the JDBC server. All the blue sections which are there, they are part of the SQL servers, or they might be SQL server, they might be MySQL or Postgres or anything that comes into picture. but the blue box is usually part of a SQL infrastructure. So JDBC client initially communicates with JDBC server. That is where it sends the queries, and those are DML or DDL queries. Then it goes through the parser and validation phase. Then the result of that is passed on to query optimizer, which optimizes the query and internally converts in what we call as relational algebra. And finally, there are data flow operators within the SQL infrastructure, which communicates with data to make sure that the results are generated. And the same way back, the results are returned back to the client. So this is a traditional architecture of SQL engines. But there's a problem with this particular architecture, that if somebody external person, if they want to use a part of this particular section, either of those four things, they cannot make use of that because they are very tightly coupled with each other. What Calcite did is a little bit of differentiation in the architecture. So they kept the JDBC client as it is. They provided the JDBC server called as they provided a layer called a JDBC server and SQL parser, which is an optional layer, and they allowed you to plug into the SQL parser APIs for you to parse the APIs on the fly. Okay. Moreover, the core of Apache Calcite comes up as query optimizer, which takes the parsed SQL and converts that to a relational algebra. And this is the place where Calcite allows you to plug the rules. Now, what I mean by rules here is that when the relational algebra is generated, relational algebra is some state of, it's basically a DAG type of workflow where for every different stage you can do something addition to what SQL really does, and that's what they call it as rules. So this is where a pluggability is provided by Apache Calcite, and that is how one can use an external person who is who wants to use a SQL language feature can use Apache Calcite project. And lastly, at the bottom layer, we have third-party operations. So these are the ones which actually communicates with the store. So the store can be a Edge-based store. It can be some NoSQL store. It can be a SQL server and so on, whatever it might be. So what Calcite has done or allowed us to do is it has isolated all these layers so that one can use whatever layer they want to at their own convenience. So, and this is the architecture that we have used to integrate SQL syntax into Apache Apex. Now a bit about expression tree. Sorry. So let's take a look at the SQL select statement that is provided at top. So select statement is basically reading the data from two tables. One is a product table and one is a Splunk table that is coming from Splunk. It is doing a bunch of aggregation, a little bit of operations. It is putting some condition and finally ordering the data. So the relational expression tree or relational algebra of this same SQL statement can be converted as what you see at the bottom. Okay. So the first layer is a scan type of operator which reads the data from the Splunk table. In case of this might be coming from MySQL. So this might be coming from Splunk. So scan operator is reading the tables and sending it to the next operator. That is a join operation. Now join is joining the data on the product ID key. So you can see that there's an on condition here on product ID. Then it puts a filter here on the action. Finally, it does a group by, that is an aggregation operation, and finally it comes down to sorting of the data. The one peculiarity that you see here is this is how Calcite works, and it has allowed us to read the data from two different types of sources. One is Splunk, another is MySQL. So because of the flexibility of that we saw previously, that we can have pluggable different types of third-party operators, we could do that. But there is a catch here. Okay? Now the question is that this expression tree can be complex because we know that the join operation is fairly complex. Can we simplify this? Okay, and this is where the default optimization rules of Calcite kicks in. What it does for the same SQL syntax, it identifies that this where condition, that is s.action equal to purchase, this action is applicable only and only on the table which is provided in Splunk. Okay, so what it does, it moved the filter from here to before join. So it moved the filter table from here, filter operation from here. What it helped in is the number of records which are entering the join operation are lesser now. So we are saving some cost here. So that is how the optimization of an expression tree is also done by Calcite. So such default rules are already present there. So just to quickly recap on what rules means. A rule means that an expression, the query optimizer takes the SQL statement, parsed SQL statement, converts that to a relational algebra and applies a bunch of rules in that. The output of the rules is some other set of relational expressions. So this is the first set of relational expression. After optimization rule is applied, the relational expression tree becomes something like this. So that is an optimization which Calcite allows you to do. This is the basic idea behind why we wanted to use Calcite rather than developing our own SQL parser, because it provides most of the SQL functionalities that are required for us. Now jumping onto Apex and Calcite APIs. So let's take an example of pipeline that we want to develop. Okay, so we want to read from a certain Kafka topic. So we have Kafka input operator, which parses the data, which does a certain bit of projection. Then it does a filtering of the operations, and it formats the data and writes the data to a HDFS output. So to do that with SQL, this is what we do. So we have an environment created called as SQL execution environment. So one can do SQL exec environment dot get environment. So this is going to give an SQL execution environment to the user. Dot register table. So register table is going to register a table with the environment, and table is an abstract entity. So a table can be a Kafka topic, table can be a file source, table can be a JDBC table, it can be anything. Okay, and the flexibility provided here are in terms of implementation of what we call it as endpoint. So we have an implementation of one of the implementation of endpoint is Kafka endpoint. That means the read and writes are going to happen in the Kafka. So in this particular line, so register table, it register a table called as orders, and the definition of the table is a Kafka endpoint. So and the brokers can be provided here, the topic can be provided, and it also can mention that what is the format in which data is going to be received from Kafka. So this is where the message format can be mentioned. So message format is another interface where you can implement a CSV message format, which is a message format type. You can JSON message format and so on. The other table which we have registered with SQL execution environment is a sales table. Okay, and this is where we have used file endpoint. So now the destination or the source is a file now, and we have provided this a bit of configurations to it, that is like destination folder, file name, and finally again the message format in which the data needs to be written. Okay. Now one peculiarity that you see here is that whether the orders table or sales table is input table or output table, we are not mentioned, because the Kafka endpoint and the file endpoint interfaces are implemented in such a way that it can be anything. It can be an abstraction of a table. So we assume that either ends are both having read-write permission. So that's an abstract assumption that we have made. Moreover, another thing that we are allowing user to do is register custom functions. So one can define a static method in a certain class, give it a name, and register that as a method to be used in SQL syntax directly. Now, once this is done, this becomes our SQL execution environment. The next step to this is execute a SQL statement. So to do that, what we say is insert into sales. So the sales table now becomes an output side. Select stream from row time. Row time is one of the column that is received from the data in the input side. Then we do a flow of that. So this shows that a little bit of projection and transformation can also be done in this. We do certain level of concatenation and substring. So this is an Apex concat method that is custom defined, and so this method will be called directly. From orders. So because it is a from orders, then the orders table that is defined here becomes an input source. And we put a filter with where clause and another filter with like operator. So all these things basically gets converted down to a DAG internally by Apex engine. So essentially the CSV parser is going to parse the lines received from the Kafka using this particular CSV format. The project operator will be used to construct these fields which are being provided in the SQL. Filter is going to make an where clause argument and also the like. And again, finally, CSV formatter is going to convert the data that is in the processable format to a writable format. And finally, the line writer is going to write that to the disk. The disk can be HDFS or local files, doesn't matter. So that's how the APIs of Calcite looks like. Now the next phase of the topic I have is a bit of demo where I will show how things will look like. But I just want to take a logical break there and want to ask if there are any questions anybody has. You can raise your hand if you want, or you can type in the questions. Okay. All right. So let's go ahead and show you guys a little bit of demo. So I'm going to show you a piece of code which is present in Moila library. So so this is an open source library which is where you can go to demos, then SQL, and this is in project. Is there a question? Yeah. Yeah. You can unmute the person. Just click on here. Jay, can you speak? All right. Jay, we are having some technical issues related to unmuting you. So would it be okay if you type in your question and we'll answer that? So okay, let me read it out for you. Jay asked a question that how is the exception handled under the custom functions. So basically, this is a static method which is there. So technically, a static method needs to handle the expression of its own. Usually, what we do is we capture that in try and runtime exception, and write exception or write result can be returned as a part of this function. But one is free to not do that and provide an exception handle at a calcite layer also, so that that can be taken care of. Think about it this way: if the concatenation function, or we can see that there's a substring method, right? Substring method is provided by SQL. If substring method throws an exception, the SQL query fails, right? So we want to keep the behavior same. That's why we haven't put any exception handling in that case. But one is free to do that of their own in that particular method that is defined. All right, let's. Yeah. So okay. So there is one more question. What is the relation between Kafka and Apex? So Kafka is basically a messaging pipeline, which is your audio connection is lost. Attempting to reconnect. Okay. Hi guys, are you able to hear me? All right. So, there is as such no relation between Kafka and Apex. Kafka is a messaging bus which is provided as another project by Apache. It is a very high performant bus. we have developed Kafka input operators to read the data from Kafka topics at the rate that it supplies. And we also have output adapters, which helps make sure that the data is inserted into Kafka topics at exactly one's rate. But as such, from a project's perspective, they are two independent projects. Any other questions? Okay. So let's jump on to the presentation, the demo part of it. So, code that I'm going to show you is actually already present in demos and SQL folder. So I'm going to demonstrate the same code sequence. But I want to walk through the code and show a couple of APIs which are present. That's why I'm going to open my IDE. Demos, SQL. So there are a couple of ways in which we have allowed Apex to okay. Is the audio better now? Okay, cool. So there are a couple of ways in which Apex allows you to create a DAG uh, using the SQL statement. So this is one of the ways that we want to showcase. So the first, as we saw previously, the SQL execution environment, you can get an environment of that SQL execution. So what we have done is the same piece of code can be put in the popular type API of Apex. This is where one would develop or construct DAG. Okay, and we want it to be in line with what other type of non-SQL type users use the APIs. And so we have created the APIs for the purpose of popular tag. So in this case, we have created we have registered a table which is present from picked up from a configuration. I'll show you how that configuration looks like. And we have given a file as an source for it. And finally, we have executed the SQL statement that is provided using the SQL execute SQL. Okay. Now let me show you the properties from which this con.get variable is reading from. So this particular thing, CSV schema in name, is picked up from here. So this becomes an orders table. Okay. For the messaging format, the schema in, that is CSV schema in property, that is this. So this defines that how the data is presented in what format and how to parse it and so on. It also provides the file source file. Okay. The source file here. So the source file is picked up from another directory called as user my test. This is my local installation of Hadoop that I'm going to pick up from. And finally, the SQL statement that is executed something like this. Okay. You would have noticed a little bit of difference in normal select statement and this one. There is a stream keyword that is present. The purpose of this keyword is to make sure that this tells to the Calcite engine that this is a streaming query. That means don't wait for all the data to be retrieved. Just process the data on the fly. Okay, and that is how we wanted to develop an streaming application, or basically a real-time application that we have recommended that stream keyword to represent. But technically speaking, there is no other difference in the SQL statement that one knows about. There are a couple of other types of APIs present. Another API is present. This is actually the same API, but I've created a different, bigger application here. So where I have register table here. I have another register here, which is a definition of the file output. A function is registered and execute sequence, select sequence. This is the one that we just saw. So this is the one that we just saw in the presentation slides. Okay. There is one more type of syntax that is present, where you can say that a pipeline is already constructed and a subset of that pipeline you want it to implement as a SQL interface. So this is where we say that an implementation of an endpoint is called stream endpoints. So this is where we say that a port of an operator becomes an abstraction for the table. Okay, so you can have a part of the pipeline being already constructed, and subset of that pipeline, rest of the pipeline becomes an SQL. So I have Kafka input operator here, I have a parser here, okay, and the output of the parser, CSV parser out, becomes a stream endpoint. Is the audio better now? Okay. So this is also another set of APIs. I was saying that one can say that a port of an operator becomes an abstraction for the table, and the table for that particular port can be used directly in a sequence syntax there. Okay. So what we are going to look at is this particular set of this particular application, and we are going to show you how it gets launched. Now, one of the things that I want to make it a point that this is a select statement and there is no insert there. So that means that we have not provided a destination table where the result of the dataset should go. So to make sure that we still show a result to the user, what we have done is we have put something called as console output operator, which is basically an std out, and which outputs the results to an console output. Okay, so let's try and launch the application. Right, hopefully my Hadoop is running. Okay. So we are just launching the Apex CLI here. Okay, just took a little bit. All right. So I'm going to launch the application that is shown. So there's an API file which gets generated when I compile the project. So I'm going to launch that as a API file. And as we saw, there are 4 applications generated here. The Apex CLI allows you to select one of the applications that can be launched. So I'm just going to launch the 3rd application. Okay, and you can see that there's an application which is launched. Okay, it is just application master has launched for it. Let's give it a couple of seconds. Sorry, man. This is my development box, and okay, I think it is starting to. Okay, fine. So you can see that the application is still starting, but by the time it launches completely, let me tell you that the file in our application, the file endpoint and the CSV message format put together has created a sub pipeline of file input operator and a CSV parser. The select statements that we have provided here has added a projection operator, and there's a logical delta operator, which is nothing but a console output operator, which is provided. All right, the operators are not starting up. So as of usually this doesn't take this much time, but this being my development environment, I need to tune some things to get things working faster. So you can see that there are tuples being processed and emitted. So I can show you the output. So basically the output at the console output operator. So it's something like this. So the data at the input side contain a bunch of fields, but at the output side, this being a POJO, this is how it is printed. Console output operator is just going to take the data and calculate the toString method of that and print it. So the project operator is going to return a POJO. That's why this is how it is printed. So you can see that there are only two fields which have come up now. Okay. So as a result of this application, what we can conclude is that one can just define this execution environment and launch a select SQL statement on that, and as a return of that, an Apex application DAG gets launched. All right. So as a part of this session, that is all I have. So these are a couple of resources which are there. So you can visit the Apex website, subscribe to the forums which are there. DataTorrent has provided a sandbox environment for somebody to try out Apex very easily. So one can go to that download page and download a sandbox. It's a VM. It's a ready-to-use VM. One can use that, or even a Docker variant is also present for that. And there are meetups that anyways you guys have registered. Webinars are also there. All the videos are basically shared on youtube.com. You can go to users DataTorrent link and you can see all the videos of all the previous webinars also there. So the slides are present on SlideShare. And lastly, we have DataTorrent has also provided with app hub templates, which are basically a set of templates that we have found out from a user interaction that they're useful to them. So user just downloads the app hub templates, they configure it and launch, and they're good to go in production as well. So that's all from my side. Are there any questions that I can answer? Okay. Thank you, guys. If you have any further questions, okay. The question is, who are your big customers? So what I'll suggest you is you can visit the DataTorrent website, or you can visit the Apex website also. We have a page for powered by. You can see that page, or if you have any questions, you can contact us through the DataTorrent website also, and we'll make sure that your queries are answered. There is a dev at Apex and users at Apex mailing list also. You can communicate via that for any questions that you have. Okay. Thank you so much, guys. Thanks a lot.